Hey everyone, so here's our lesson on reflections. So reflections are another type of transformation. It is when you take a shape and you flip it over a line. The line is called a line of reflection. So we have different types of lines that we use as lines of reflection all on the coordinate plane. Here's an example of a reflection that's not on the coordinate plane. We have this A, B, C, D. This is the pre-image. Remember, that means that's the original one. And it was flipped over this line of reflection, line L, and this is the image. Notice that all of the points, the image and the pre-image points, are the same. Each individual pair, like C and C prime, are the same distance to the line of reflection. B prime, same distance to the line of reflection. So that's what happens with reflections. Now, ours are all going to be on the coordinate plane that we're going to do. So this little chart here just has like the common lines that we reflect over. So oftentimes we reflect over the x-axis. And so when we do, you'll see in the example, just like count to the x-axis and do it visually. So let me just say that with reflections, you can use these coordinate rules. That's what these are called, coordinate rules. Or you can just do it visually, like look at the line, look at the image, and then like count and figure it out that way. So for a lot of these examples, I'm going to show you how to do it both ways. There are certain lines that a lot of times kids use the coordinate rule. So let me just explain real quick what these coordinate rules mean. Do you see how some of them have negatives? Anytime a coordinate rule has a negative, it just means to change the sign. So I'm just going to write that little note over here. So a negative in a rule means to change the sign. Okay, so let me erase this. So if we were to reflect over the x-axis, remember that's the horizontal axis, is the x-axis. You could just change the sign of all the y values. So this coordinate rule, this is, again, x, y maps to, and then that's what you do to the points. The x stays the same. The y value, the sign changes. And so that's what you could do for the x-axis. For the reflection over the y-axis, remember the y-axis is the vertical one. For the y-axis, it's negative xy, meaning you can change the sign of the x and then the y stays the same. Reflection across the line y equals x. So first of all, let me remind you of what y equals x looks like. So say here's the x and y axis. If you think about y equals mx plus b and plotting this line y equals x, it has a y-intercept of 0 and a slope of 1. So it would go through the center with a positive slope. That's y equals x. That's what that looks like. So when you have y equals x, you can either count to the line, and I'll show you how to do that, or the rule for y equals x is yx, meaning that the x and the y just switch spots. None of them change signs. The next one is y equals negative x, which is very similar to y equals x. The only difference is instead of a positive slope, it's a negative slope instead. So it goes down through the center. Whoops, that's not very straight. I thought it would straighten it out for me. So that's y equals negative x. And the rule for y equals negative x is negative y negative x. And so they switch spots and both of the signs change. Lastly, we have reflections across lines like x equals some number or y equals some number. Like what I mean is x equals 5, let's say. If I asked you to graph that line and reflect something over x equals 5. When it's x equals a number, it's a vertical line, even though x is the horizontal axis. But x, if you're trying to plot the line like x equals 5, like I said, it would go through 5 on the x-axis, which would therefore make it a vertical line. And then y equals a number is a horizontal line. And so those are all the different types of reflections. I'm going to try to do like one of each type without doing too many. Here's the first one. We're going to reflect KLM over the y-axis. So the first thing that you always want to do is graph the line. Since the y-axis is already graphed, right? It's part of the coordinate plane. I'm just going to highlight it So we know that's the line that we're going to use. So now we could use the rule for the x-axis, for the y-axis, which was negative xy, meaning we take all these ordered pairs. But first you'd have to write them down. You have to write down all the ordered pairs and then change the sign of all the x's and then plot them. I find it actually a lot easier to just count to the line. Basically what you're going to do, anything to the right of the line, like this L right here is to the right of the line, you're just going to count how many units it is to the line. So see how L is just 1 unit to the line? So L prime is going to be 1 unit the other way. So that is where L prime would be right here. Zoom in a little bit so it's a little bit easier for me to get these points. Okay, and then M is 1, 2, 3, 4, 5 to the line. So M prime would be 1, 2, 3, 4, 5 the other way. It is, remember, important that you label with the prime symbol. Okay, and then K is 1, 2, 3 to the line. So K prime will be 3 the other way. So this is K prime. Lastly, you connect them. And so there's your reflection. Notice that if we were to fold this in half, like if you can imagine folding this in half on the line of reflection, all the points would match up. And it just goes right down the middle of them. Okay, so there's our first one. Our next one is we're going to reflect over y equals x. So again, the first thing that you want to do is graph the line. So y equals x has a y-intercept of 0 and a slope of positive 1. So it goes through like this. Whoops. So there's the line of reflection. So next, okay, so here we go for this. This is a diagonal line. So if you're going to count to the line, here, this is an example where I'm going to show you counting and using the coordinate rule. If you're going to count to the line here, you have to count it diagonally, which sometimes is tricky for kids because it's a diagonal line. So like, see how L is one diagonal, like it has to go corner to corner. So then L prime will be one diagonal in the opposite direction. So here's where L prime would be. K, you can also count like horizontally and then down. That's another way to do it. I can show you that too. But K, if we're going to count diagonal boxes to the line, there's one diagonal box, 2, 3, 4. So K prime would be 1, 2, 3, 4. So here's where K prime should be. I'm going to erase that line just so it doesn't get too confusing. Okay. Next is M. So M is 1, 2, 3 diagonal boxes. So we're going to go 1, 2, 3. Ooh, move this up a little bit. So right here is where M prime would be. Again, I'm just going to erase those lines so it's not too confusing. And then lastly, we can connect our points. So normally I would have you guys like definitely use a ruler, but since some of you are at home or whatever, just do your best to make straight lines. So that's what it would look like when reflecting over y equals x. I do just want to quickly show you how you would do it using a rule. So if you look back at the chart at the top, the rule for y equals x is xy maps to yx. You simply just take the points and flip them. Switch x and y. So k right now, the pre-image was at -3, 5. So k prime would be 5, -3. You just swap them. L is at 1, 3. So L prime is at 3, 1. And then lastly, M is at -5, 1. So M prime would be 1, -5, which we already found these points, right? So if you were doing it not the counting way, if you were going to use this method, you would then take these points and plot them. So that's how you do it with the coordinate rule. Okay, the next one is the line y equals 1. So remember in the chart, I talked about the line y equals 1 is a horizontal line through 1. So that's y equals 1. This type of line doesn't have a rule to use. You just kind of count to the line. So like kind of like we did in the first one. So if I were to do L, L is 1, 2 units to the line of reflection. So L prime would be 1, 2 units down. So here would be L prime. M is on the line of reflection, so M prime stays on it. Just relabel it. And K is 1, 2, 3, 4 units to the line of reflection. So we're going to go 1, 2, 3, 4 units down. And that's K prime. Oops. Don't mind my messy lines. Okay. And so there's y equals 1. It's flipped down over that line. The next one is y equals negative x. Remember, y equals negative x is kind of like the second example, y equals x, except it's a negative slope instead, so it goes down. So let's see. Okay, perfect. So now again, you can count diagonal boxes. So K is one diagonal box, so K prime would be one diagonal box. Oops. Okay. M is 1, 2, so M prime would be 1, 2. So here would be M prime. L is 1, 2 that way, so L prime 1, 2 this way. So here's L prime. Just gonna erase some of these lines so it's not so messy. Okay, then you would connect. Sometimes they really overlap each other like this one, and that's okay. Now, if you're gonna do this using the rule, you would use these same points up here that we found. The rule for y equals negative x is negative y, negative x. You flip them and change their signs. So K was originally at negative 3, 5. So K prime, we're going to flip it and change the sign so that 5 becomes negative and then negative becomes positive at negative 3. L was at 1, 3. So L prime would be at negative 3, negative 1. M was at negative 5, 1. So I'm going to flip it, change the sign. M prime would be at negative 1, positive 5. And that's how you would do one like that. And again, I don't care if you count or if you use the coordinate rule. It does not matter to me. Okay, so there is kind of like one of each type of example. On the second page is identifying the line of reflection. So basically how you want to do this is kind of like try to find the middle, like just visually look at it. And I like to draw the line of reflection before I start thinking about the equation. So if I see, I'm going to like look at 2 points, B and B prime. I notice B and B prime are both on this horizontal line. They're 6 units apart. So the line of reflection is always directly in the middle because the points have to be the same distance to the line of reflection. So that means it's going to be at 3. So this right here would be your line of reflection. And so then you want to think about what equation that is. That's a vertical line through 1. So that's the equation x equals 1. So this pre-image was reflected over x equals 1 to get your image. Okay, the second one. Again, you can just pick like a pair of points like L and L prime are 4 units apart. So at 2 units, that's your line of reflection. Which, and rather than saying the equation, you can just say that this one is reflected over the x-axis. Okay, this next one, take a look, see if you can figure it out. If you need to, look at S and S prime, see how far apart they are, find the middle. Or look at R and R prime. Well, they didn't actually relabel it. They should have. It's right on the line of reflection. I don't know if you can tell that, but this is the line of reflection here, which is a vertical line through 4. So it's going to be x equals 4. And then here's our last one. Hopefully you can tell this one's on a diagonal. So this one is actually this corner to corner diagonal one, which that one is the one with the negative slope. So that's y equals negative x. And so that's it. That's reflections. Please let me know if you have any questions. And that's it. Have a great day.